Hey guys, how's the studying going? Tonight we're going to talk about astronomers and their role in our discoveries in the universe and of course the grade 9 science curriculum. Before we start, I'm going to touch on some terms that may come up in our studies. So first there's an astrolabe, and this was usually used in conjunction with a compass, and it was an instrument that helped scientists and astronomers to predict the positions of celestial bodies such as moons and stuff. Then we have a telescope, which most of us are familiar with. It's an optical device that uses lenses to focus light and magnify the view of an object. So things that are very small or very far away, it helps us to see them better with more detail. Then we have an ellipse, that is the distance from a focal point to an edge and then to another focal point. No matter what focal point or edges you use, this distance will always be the same. So first up we have Aristotle. He was a very important person. He thought that the Earth was geocentric. This is the theory that the Earth is at the center and the celestial bodies orbit around it. So the other 7 planets and the Sun was thought to orbit around the Earth. He looked at patterns in the sky and saw shadows on the moon during a lunar eclipse and said because of this, the Earth had to be a sphere. He also noticed that in the north and south, you see different constellations. So this is a throwback to our last video and the term circumpolar constellations. So the opposing view to geocentric is heliocentric, and that's the theory that we accept today, and that's that all celestial bodies, us 8 planets, orbit the Sun. Next up we have Aristarchus, and he said that Aristotle was wrong, and that the Earth is the universe is actually heliocentric. And no one believed him because everyone thought that if Aristotle figured out that the Earth wasn't flat and that it was round, then maybe there's something to it, and maybe he's very smart. So they believed him, and Aristarchus went on anyways and was the first person to attempt to measure the distance to the Sun. Forgive me for how I pronounce this, but then we have Eratosthenes of Siena. He was a mathematician and astronomer, and he was the first person to attempt to measure the diameter of the Earth. He was very close. What he done was put 1 stick in the north and 1 in the south, and on the longest day of summer and winter, he measured the angle of their shadows, divided it by 360 since the world was round, and got a very close estimate to what we actually know is true today. Then we have Ptolemy. He helped coin the term retrograde motion. This term means the motion in the sky that changes. People didn't know what to think of this when they realized that Mars traveled in an S shape and then pivoted before it returned back in that S shape. So that's what this means. He showed this by developing a model of the solar system which illustrated each planet being attached to an off-center wheel, which is an axis. This theory was accepted for nearly 1500 years. That's a long time. Then we have Copernicus. He was an astronomer, mathematician, priest, and physician. A lot of times back in the day, as we'll see coming up, religion and science didn't go well together. I guess that's true today too, hey? So he said, guys, Aristotle is wrong. The universe is heliocentric. He discovered the heavens' rotation, the movement of the sun, and the periodic retrograde motion of planets. People who supported his heliocentric theory were punished, but not as cruelly as some coming up. Then we have Giordano Bruno. He agreed with Copernicus and said that the Earth, or the universe, was heliocentric. He said, the universe is way bigger than just our own. There's tons of other suns, planets, and maybe even life out there. People really thought that this was opposing religious views, and back time religion was huge, so he was burned at the stake for believing such tomfoolery, I guess. Then we have Galileo. We've all heard of him, I'm sure. He was the first person to use a telescope. As a result, he's seen celestial bodies that were never seen before, and even though his telescope was very weak, he's seen more than people have ever seen before. He's seen craters on the moon, spots on the sun, and moons, which he thought were stars, orbiting Jupiter. He's seen 4 of them. He also observed the phases of Venus and said that it was only possible if the universe was heliocentric. People still didn't want to believe that the universe was heliocentric, so he was imprisoned for the rest of his life because his beliefs contradicted the church. Then we have Johannes Kepler and Tycho Brahe. They worked in union to learn about the motions of planets and their orbits. Together, they developed theories of planetary motion and using mathematics and observation. Kepler then went on to do 3 laws of planetary motion, which we still accept today. They are all planets moving in ellipse around the sun. We know that's true. We all orbit the sun. Planets also sweep out equal areas of their orbits in equal times. So the speed of the planet isn't constant because as it gets closer to the sun, it speeds up, and the farther away from the sun it slows down. So that's like Earth and Neptune. We move at different speeds, and of course Neptune has more area to sweep out because it's farther away. Lastly, the time it takes to orbit around the sun is directly related to its distance from the sun. So planets farther away obviously take a little bit longer because they have a lot more distance to cover. Then we have Newton. He's the Apple guy. Most famous and biggest influence. So we can think back to the apple falling on his head or his 3 laws of motion. He showed that gravity extended farther than the Earth's surface and was actually the cause of planets orbiting around the sun. He also discovered the refraction of light, the prism, the white light, the sphere, and invented the reflecting telescope. The refracting telescope is a telescope that uses a curved mirror and focuses light onto a point of the eyepiece. It's larger and more precise, so it's called the Newtonian design. That's all that we have for right now. Thanks for watching, and hopefully there will be another video up soon for you guys to watch, and I hope that it helps you with your tests. Thanks.